Hello, I'm looking forward to talking to you today about smart connected manufacturing operations. Historically, when someone from Kalypso has addressed the PI Apparel team, it's likely been on functional topics around product innovation, design, development, and sourcing. But today we're going to shift gears. We're going to focus on the factory, on the manufacturing operations. So what I first wanted to do was provide some context about what we see happening in the transition of the global landscape for manufacturing operations across the globe. So if you look in the first column, long before COVID hit, we were tracking 7 key trends that were driving the need to rethink the global footprint for manufacturing for retail footwear and apparel. I'll just give you a second to kind of look down through those. I'm guessing most listeners are pretty familiar with most of those. But what's happened with COVID is many of those have been accelerated and or exaggerated during that time frame. And what that's led to is accelerating the path where clients and customers have been focused on diversifying away from strictly an offshore production model and shifting to really a mix of 3 models. So we'll continue to have offshore models as being probably the primary model for our industry for a while, still focused on low cost centers, primarily focused on products with low demand variability in long production runs. But we've already seen the acceleration of the move to more nearshore models, with more responsive centers closer to the point of demand, with products that have moderate to high demand variability, with lower production runs and more changeovers. And in this case, the relatively higher labor costs are offset by lower overall inventory levels and risks. And then finally is the rapid emergence of onshore models, especially under COVID. And this is in-country production centers, usually with products with very high demand variability, and especially now used for sample production in small runs for testing products through direct-to-consumer channels. And again, the relatively higher labor costs are offset by lower overall inventory levels and risks. So in the pursuit of trying to diversify across these 3 kinds of models, companies have basically been pursuing 3 things at the factory level. So the first one is optimizing existing factories. The second is acquiring and renovating existing factories that may be owned by somebody else. And then the third is building new greenfield factories nearer to the point of demand. So what that's done is that it's created the opportunity to rethink again what the factory of the future looks like in apparel and footwear. So footwear and apparel has been a relatively late adopter of automation and other advanced technologies and techniques that come out of the kind of Industry 4.0 thoughts. But what I'd like to argue today is that many of those concepts are already beginning to show up in our industry, and it's time to take advantage of that. So going forward, I want to talk about 4 things. I want to talk about in the future, how do we measure success? I want to talk about several use cases for improvement at the factory level. And then I want to talk about the supporting or enabling technology from an information technology standpoint and an operating technology standpoint. So before we jump into the details, what I'd like to do is introduce the concept called the digital thread. So Kalypso, we created this to be able to depict the end-to-end process from ideation all the way through commercialization of new products. So let me just orient you a bit to this slide. So across the top, you see the 4 key steps we think are comprised of the digital thread: discover, create, make, and sell. The second thing I want to draw your attention to are the icons and words throughout the digital thread, which are meant to depict the key activities and work steps and processes that occur throughout this end-to-end digital thread. And then lastly, I want to draw your attention to the dotted lines. And those dotted lines are meant to depict the information and insights that flow through the digital thread and connect these key activities and work steps. So a couple things I would note here. So first of all, you'll note that none of the dashed lines are left to right arrows. So they can flow in any direction here. It's meant to move away from a linear progression of activities and making it look more like a whole system of information sharing. The second thing I want to communicate is that this is not a functional view of discover only or create only or make only. that we really view this as an integrated whole, that this digital thread is what's required to be connected to be effective throughout the digital thread. So today, I'm going to take a particular dive and focus around the make part of the digital thread. So we think to bring the digital thread alive in general, and specifically at the factory level, is through the use of information technology. And so we've identified 5 sets of technologies that we think enable these activities throughout the digital thread, and particularly at the factory. And more, we think of these technologies as a platform rather than a set of individual technologies that are connected through integration activities. So let me first call your attention to the right side in the foundational product technology. So this is about deploying core applications like PLM, ERP, DAM, and PIM to facilitate the product development lifecycle and to store and share critical product data. Next, I'd like to draw your attention to the left-hand side to digital product creation. So this is about leveraging digital assets and tools to discover, create, make, and sell products better, faster, and cheaper. And so we think this is more than just about the 3D design tools. It includes things like digital avatars, AR, VR, and other related technologies around 3D. Next, I'd like to draw your attention to the top part of the slide around advanced analytics. So this is about harvesting insights to make better innovation design, development, sourcing, and production decisions, especially through leveraging machine learning and AI. Next, I'll draw your attention to the bottom left under smart connected products. So this is about putting products on the grid to optimize flow, tracking, authentication, and product functionality. So immediately I would think of RFID as an example of a smart connected product application. And then finally, on the bottom right, smart connected operations. So this is about optimizing operating efficiency and effectiveness in the factory using information technology and operating technology. And when I say operating technology, what I really mean is Internet of Things enabled equipment on the factory floor, like cutting machines, sewing machines, and material handling machines. So now let me jump to talking about measures of success. So probably one of the most important KPIs at the factory level is overall equipment effectiveness, or OEE. So we think about improving OEE through a series of improvement levers. So if you look at this chart kind of on the left, kind of the 2 main categories or buckets around OEE improvement are optimizing downtime and optimizing uptime. And then particularly in the middle here, there's 3 sets of levers. So the first one is mechanical availability. So that's about increasing asset reliability through the use of machine health monitoring. And then reducing downtime through the use of smart maintenance scheduling. And then under utilization management, it's about faster response time using event-triggered notifications. And then also increasing asset productivity through the use of smart production scheduling. And then finally, under production time, the levers include increasing production yield through the use of process control optimization. And then finally, reducing quality, incidents, rework, and scrap through the use of predictive analytics. So now I'd like to talk about how we go about achieving or employing these levers to achieve an outcome. So I'd like to talk about now our use cases. So these are 6 high impact use cases we've identified to improve overall OEE through the use of technology. So let me go through these one at a time. So the first one is smart rapid product development via end-to-end digital connectivity between product development and manufacturing operations. And an example in apparel is 100% confidence in artwork and color accuracy from the designer to the print shop floor. The next one is resource monitoring and optimization on the factory floor via smart planning and scheduling for labor, materials, and tooling to improve overall productivity. And here an example would be for apparel would be smart scheduling your shirt folding machine to better optimize utilization and throughput. The third use case is production performance management with the real-time metrics, dashboards, that enable OEE improvement and lean production management techniques. And here, an example in apparel would be AI algorithms for assembly line balancing to reduce machine idle time. The fourth one is process control optimization that applies machine learning to prescribe improvements to process control, production yield, and product quality. And an example here in apparel would be automatically setting optimal settings of a washer to ensure consistency on a denim line. The fifth one is asset performance management to transform maintenance and reliability of assets with fault detection and prognostics, delivering increased uptime and performance. An example here in apparel would be successfully predicting and preventing failure of an automated packing machine. And then the sixth and final use case is augmented factory operations using augmented reality and object recognition to centralize engineering support and enable faster, safer repair of equipment on the line. And so an example here would be a remote virtual recalibration of a cutting machine, saving hours of downtime. So let me talk next about how to take these use cases and bring them to life through technology. So a lot here on this chart, so let me just orient you to this chart. Overall, what this chart is meant to depict is what I would call a conceptual technology architecture for the entire digital thread. This is not meant to be an exhaustive representation of everything that might be in the digital thread. So you note in the right here, we have labeled this as representative. So let me just start with the top left. So if you look at the top left, that's our discover and create section. You'll notice that it's initiated with 2D and ideally with 3D design. And then that information then is ultimately fed into the retailer or corporate PLM system. I'd like you to also note that there's some arrows coming out of that going across the top, and you'll see on the top right then that information, especially the 3D asset, is then connected to a digital asset management system that ideally is the same set of assets and the same DAM that is used to support e-commerce and digital marketing. So now let me draw your attention back to the left again under Discover and Create and find the retailer PLM. So the next connection then is that handoff from the retail PLM into a manufacturing PLM using or what we would call the technology transfer. So think about this as the transition from the design bill of materials into the production or manufacturing bill of materials housed at the factory level. And then you'll see that the PLM, the manufacturing PLM, kind of to the top right, should be integrated and connected to your ERP system. But you'll also note there almost in the middle is that PLM system is connected to a manufacturing execution system, which is really the brains, should be the brains of guiding the factory. And then kind of to the bottom right of the MES system, you'll see what I described earlier as the smart connected equipment that sit on the shop floor. So I know it's hard to see, but that's meant to depict the internet-enabled cutting machines, sewing machines, and material handling machines that are feeding information to the MES and receiving information back from the MES. And then finally, what you'll notice is that underlying all those activities that I just described is an enterprise analytics platform. And if you look at that platform kind of going left to right, is that platform has the ability to ingest data or acquire data, and then take that data and house it in a data lake and cleanse it, enrich it, attribute it in a way so that it will be useful for analytics. And if you keep looking to the right where it says data analytics, the analytics platforms and solutions have the ability to draw on the data lake and develop models and train models to conduct the kind of analysis that will allow us to do prescriptive and predictive analytics. And then finally, that information that is then shared, the analytical insights are shared through some sort of user experience, which could be a platform, a dashboard, or many other ways to visualize the data. So again, just take a step back. We think that you have to think about this entire landscape as a sort of an enterprise architecture for product and think about deploying technology across this landscape more as a platform rather than individual applications that get connected along the way. So now I'd like to hand it off to Quach, who's going to talk about how PTC can make this digital thread come to life.
Okay, great. Thanks there, Steve. Really appreciate the handoff there. Before I actually talk about how PTC technology can actually help out, I do want to come back to this particular slide because it presents some really interesting use cases. And in fact, what I'd like to do is actually talk about how PTC technology can address 2 of these 6 use cases, namely smart rapid product development and then also production performance management. Now, when we think about either one of those use cases, what you really need is an end-to-end digital transformation platform that can cover how you as a retailer or brand plan products, how you design and develop and conceptualize those and create a spec, how you source them and determine what your development factories and your production factories are, obviously how those factories make those products, and then ultimately how you sell and bring those products to market. To achieve this entire end-to-end, let's just say, process, what you really need is a platform that can do multiple things. First and foremost, you need a PLM platform that can manage everything from the assortment planning to the design, development, and sourcing and costing. You also need a connectivity platform, which we have through our ThingWorx line of products. And ThingWorx, really what that does is it enables connectivity to devices, people, and systems so that you can gather insights from, let's just say, multiple systems of record, like a factory MES system like Steve referenced, or an ERP system, or even a CRM system. Of course, you also need a set of, let's just say, factory-specific connectivity applications, which we have through our partnership with Rockwell in a product suite that we call Factory Talk. And what that does is it's a suite of applications designed specifically for connectivity for factories and all the systems and equipment within that factory. What we also have as part of this platform is an analytics engine that can help predict different insights as well as prescribe choices for users as well as operators so they can either avoid problems or affect a positive outcome. And then finally, as part of this end-to-end digital transformation platform, we have Euphoria, which is really an AR offering, augmented reality offering, that allows you to create and deliver AR experiences such as AR-enabled remote assistance for helping factory users, as well as AR-enabled training and factory instruction delivery. Now let's actually get to some of those use cases that I was talking about earlier. The first one I want to touch on is smart and rapid product development. So with that platform that I just mentioned, one of the great things about it is that there's an opportunity for us to leverage connected manufacturing information and feed that into the design and development process. When you really think about it, right, how often do designers or product developers understand the design and development impact that they have to manufacturing processes and operations? Let's just say a footwear designer. Does a footwear designer really understand how the construction of the midsole or the toe cap or the vamp impact factory steps down the road? And does that designer or product developer really understand whether or not those design decisions impact the cost as well as the time to manufacture? More often than not, they don't. So wouldn't it be great if we could actually give them insight into the impact of their design choices? And better yet, wouldn't it be great if we could actually predict the impact of those design choices and then prescribe changes that would lower the impact? So that's what this really is all about. It's about design for manufacturing, right? It basically takes product development information that you might be housing within a PLM system. It combines it with key manufacturing KPIs based on process steps, and then it applies artificial intelligence to that in order to predict the, let's just say, impacts of those design choices. From a data point of view, what's really nice about this particular example is that data is coming from everywhere. It's coming from PLM with material information, spec information, construction information. That information can also include supplier data as well, right? Meaning the cost for a particular component. It also can include assembly information, such as the needle system or the stitch type, or in terms of footwear, even the sole assembly method. And of course, it can also include purchase information. But by combining all this information and applying artificial intelligence to it, what we can do is then determine what we call an ease of manufacturing index, right? And that EOM index, ease of manufacturing index, can do things like predict cost as well as predict time to make. And we can then deliver all that information very easily to a very visual dashboard, a very easy to use and understand dashboard to the designers and product developers that are designing these particular products. In this case here, as you can see on this dashboard, we can very clearly show an EOM index from 1 through 10, and 10 being very complicated and hard to make and costly to make, to number 1, a score of 1, which would be easy to make and low cost. So we can give them immediate insight into analysis of their designs. But what we can also do here is prescribe changes to their designs so that they can understand if they actually made this particular tweak, the EOM index, or the ease of manufacturing index, can actually be reduced, right? So particularly here, you can see this table of recommendations where there is a recommendation to change the factory that's being used for the midsole, as well as the needle system that's being used for the quarter vamp here. So with this easy to consume information, we can influence manufacturing up front, right before it's too late. We can tell the designers and the product developers, hey, if you make this particular change, yet adhere to, let's say, your aesthetic design still, we can actually be more profitable, or we can actually release products to market faster, or we can actually release products with the level of quality that's required. So hopefully you can see here why the combination of manufacturing data that's coming from the factories, as well as combining PLM data that captures the design of a product and the application of AI against all of that data, all that supply chain data, we can do smart, rapid product developments. Now, one of the other things that I wanted to touch on was the other use case that Steve mentioned, was production performance management. There's a significant opportunity here to improve efficiency, and we know this because we've actually have surveyed some of our own customers. What you're seeing right now is a chart that is based on a survey of one particular customer's supplier's production line data. What we did was we evaluated the production performance across 25 different factories for this particular brand. So it included approximately 5,500 different shifts. And we evaluated the time that it took for each one of these production steps in their factory line. And we evaluated that, or benchmarked that, against standard allowed minutes. So basically for every single action or operation, whether it be a cutting operation or a sewing operation, that particular operation would have a standard allowable amount of time to complete. And what was really interesting here is when we compared each operation against these SAM values, what we found out was that only about 15.5% of all operations actually beat the standard benchmark, meaning only about 15.5% of those operations completed within the allowable amount of time. In fact, the majority of those operations exceeded the allowable amount of time, which meant that people or operations were performing not that efficiently, right? They were exceeding the time that it would normally or that it should take. In fact, you can see here right in the middle, 70% of all operations exceeded the standard allowed minutes by 75% of the time. Okay, so there's a huge opportunity here to improve production efficiency, and again, we can do that with a set of connected connected capabilities within the factory. And we do that through an initiative that we call Intelligent Apparel Manufacturing, or IAM. A really easy way to think about IAM here, other than smart connected manufacturing operations, is that it creates a comprehensive link between PLM and all the different factory systems, and it gives voice to the factory, meaning it gives voice to all of the operators within the factory, as well as all of the equipment and all of the systems in that factory, so that you can do interesting things like optimize process steps, as well as optimize machinery. IAM, basically using the combination of ThingWorx and Factory Talk and ThingWorx Analytics, can really do a number of things. It can enable connected machinery, so we can provide sensors that are tied to these different machines, whether they be cutting machines or sewing machines. Those sensors then can help us predict maintenance, as well as provide connectivity to the operator with important PLM data, right? And that PLM data could be in the form of tech pack information or construction information coming from the tech pack. Now, beyond connected machines, we can also do broader real-time monitoring, right? Monitoring of not just the machine, but the operator of entire production lines, and compare that against purchase orders, and then enable both brands and factories to really understand or I should say brands and suppliers to really understand the efficiency of multiple factories at once. And of course, like I said earlier, with all that information, we can then also enable a level of optimization for all those resources, right? We can help predict KPIs and understand uptime. We can anticipate unplanned downtime. We can also analyze process steps and understand where within a given manufacturing execution process there may be bottlenecks. And then, of course, we can help eliminate those bottlenecks. And if you're interested in understanding, well, what does that really look like? Either to me as a brand, or maybe to my factory users, or to the suppliers that I work with. Here's a really great example of a visual of how we can monitor a simple sewing machine, right? In this particular case, you can understand, for example, how available that machine is, whether or not it had any unplanned downtime, and understand the overall efficiency of that. At a broader level, like I mentioned earlier, you could also understand the efficiency of multiple assets within a given production line, right? And you can see here that you can not only understand the availability percentages, but also the operational efficiency rates as well. So with that, you have really the opportunity here to understand if you're meeting, or if the factory is meeting target KPIs. And if then they're not, they can also then develop corrective measures, right? And that's a win-win for everybody. It's a win for the factory, and of course, it's a win for the brands and the retailers that use them. So hopefully this really gives you a good overview of how smart connected manufacturing operations can be used to manage production performance. So I'd like to go back to this year. We only touched on really 2 of these use cases, but there was a lot more that Steve mentioned, a lot more that we'd love to review with you. If any of you are interested in any of this, or if you have any questions, please don't hesitate to reach out to Steve or myself. Really appreciate the time that you spent with us today in reviewing everything with us. And like I said, if you do have questions, please let us know. Thank you.